Good morning, students. Okay, we are moving to our next chapter, probability. Okay, you have familiar with the name probability because in the previous class, previous year you have studied about probabilities and you know the definition. I will not go into that. Okay, I'm just starting the chapter. Okay, you have studied the additional law of probability in your previous class, and I have I am revising the addition proper law of probability with this terms. Okay, you have been familiar with this term, but I am just revising that. Okay, so what is a simple event? Okay, you know the terms. Okay, the terms in probabilities are very, yes, it is very important. The terms are very important, so you know about the outcomes. Okay, yes, you know about the outcomes, mutually exclusive event is the main thing. Okay, events are occurring in the probability and the outcomes are important. Okay, and the number of times, okay, that is also important. Okay, that are the important terms in probability. So simple event is that event that describes a single outcome. Okay, the number of times we have using that and we are getting a single outcome, it is a simple event. And two or more simple events have been made up. Okay, two or more simple events have been made up, it is a compound event. Okay, and also next is mutually exclusive event. Okay, that are events that cannot both occur at the same time. Okay, you know a die is thrown. Okay, you know there are 6 outcomes are there. Okay, die is thrown and a coin is tossed. A coin is tossed. Okay, that too is also 2 events. So that 2 events cannot be occur at a same time. Okay, event A and event B which cannot be occur in same time. That is mutually exclusive. Okay, that is example is given. When a number cube is rolled, A1 and A2 cannot be rolled on the same roll of the number cube. And with one throw of a die, a 3 and a 5 cannot be scored at the same time. Okay, if we roll or if we throw a die, the number 2 and number 4, for example, number 2 and number 4 cannot be occur at the same time. That is given. Okay, yes, that is mutually exclusive. And next is the addition law for exclusive events. That is the probability of 2 mutually exclusive events of A or B occurring is the sum of their individual probabilities. This is also you have studied in the previous class. Okay, probability, which is very important in that also. So all these equations and terms have been studied. I am just recalling it so that I am just going through this. Okay, I am not explaining, just reading this. Okay, and so P of A union B is, what is P? Probability. Probability of A union B is probability of A plus probability of B, which is the addition rule for exclusive events. Okay, and it can be say as P of A or B is P of A plus P of B. Okay, and if n exclusive events has been occurring, then P of A union B, P of A1 union A2 union etc. union AN is P of A1 plus P of A2 etc. P of AN. Okay. Next is exhaustive events. If 2 events A and B are such that between them they make up the whole of the possibility space, then A and B are exhaustive events, or P of A union B is 1. Okay, P of A union B is 1. Okay, that for example S is the integers from 1 to 10 inclusively. A is integers below 7, that is 1 to etc. 6. B is integers above 5, that is 6, 7 etc. 10, that is, then A union B is S. A union B is S. That is the exhaustive events. Okay, that is if 2 events has been such that they make up whole, that possibility space, that whole space, that is A and B has been given, A union B is S. Okay, yes. and some special cases for that also given. A is given, complementary event A dash is also given. Then probability of A intersection A complement is 0. Okay, that is a special case also. And A union A complement is S. That is probability of A union A complement is probability of S. That is. Okay, and the third one is if A and B are any events connected with a random experiment, then P of A is P of A intersection B plus P of A intersection B complement, and P of B is P of A intersection B plus P of A complement intersection B. Okay, these are some special cases of exhaustive events. And also P of A complement intersection B complement is 1 minus P of A union B. Okay, these should be studied, these have been studied in your previous year. Okay, yes. And next is inclusive events. Okay, that is that which has not exclusive event, that is the event that have one or more outcome common. It has been one or more outcome has common. Okay, that is when a number cube is rolled, the outcomes rolling an even number and a prime number, which are not mutually exclusive. Okay, that is inclusive. The number 2 is both prime and even. Okay, so the events are not mutually exclusive. Okay, yes. And the probability of two inclusive events are occurring is the sum of their individual probabilities minus the probability of both occurring. Okay, the probability of A union B is probability of A plus probability of B minus probability of A intersection B. That is the probability of two inclusive events. Okay, yes, not is given. That is even and prime. Yes, P of A intersection B is 5. Then P of A union B is P of A plus P of B. That is. And next is a problem that for how will you find it? Okay, that is a card is drawn from an ordinary pack of 52 playing cards, and find the probability of the card is a club or a diamond, a club or a king. Okay, so or is coming. So what you have to be, this is a mutually exclusive or inclusive, like according to that you have to use the equations. Okay, and problems, similar problems has been given. Okay, next is the conditional probability. Okay, that is conditional probability. Before that you have to know what is a conditional event. That is, if A, B are events associated with a random experiment of a sample space S. You know what is a sample space and also random experiment. So if a random experiment of a sample space S is happening and A occur after the occurrence of B, the event A occur after the occurrence of the event B, then the event of occurrence of A after B has occurred is called conditional event. Okay, that is the event of occurrence of A. After B occurred, that is conditional event. Okay, and it is denoted by A by B. Okay, A by B, which means the occurrence of A after B has occurred. Similarly, we define B by A. What is that? The occurrence of B after A occurred. A has occurred. Okay, that is the conditional probability. Conditional event. Conditional event is that. So, A by B is A occur after occurrence of B. That is, first what is occurring? B is occurring. First B is occurring. So, A given B. That is the how to it is read. It is not A by B. I have just reading that. It is A given B. A given B. Simply we read it as A by B. But it is A given B. A given B means B occur first. Then A. A occur after the occurrence of B. B given A means A occur first, then B occurs. Okay, this is conditional event. And what is conditional probability? Yes, it is that conditional probability is A and B are two events associated with a random experiment. Then the probability of the occurrence of A under the condition that B has occurred already. And P of B, probability of B should not be equal to 0. That is the conditional probability of A given B. And we written it as P of A given B. Okay, that is conditional probability. You know the conditional event. The probability of occurring the conditional event is called conditional probability. A given B. Okay, probability of A given B. That is conditional probability. Okay, yes. Some examples has been given. Okay, that is for that I am just explaining. In an office, out of 35 people, 18 like pizza and 23 like coffee. 2 persons like neither and neither. 2 persons like neither and 8 persons like both. So one person is randomly selected from the group. Okay, it's a group of 35 of 18. Sorry, 35 out of 35. Okay, from that you have just selecting one person randomly. What is the probability that, okay, the person like pizza given that he or she like coffee? Okay, yes, like pizza it is easy. P of pizza, P of that is 18 by 35. Okay, that is according to that Venn diagram it is easy. And also P of pizza given coffee, that is what is that? Pizza given coffee, it is given 8. Okay, 8 by 23. Yes, coffee 23. That is the number, the sample space for pizza. That is pizza given coffee is 23. Sample space is 23. So the number denoting it, number of person who like coffee is 23. That is 8 by 23. Okay. Yes. Okay, then in problems, how will you evaluate P of A given B? For A and B, with any two events, which is not necessarily from the same experiment, it does not be from the same experiment, then probability of A given B, that is probability that A occurs given that B has already occurred. It is given by P of A given B, or P of A by B is N of A intersection B by N of B, where probability of B not equal to 0. N of A intersection B means, yes, the number of cases or the number of outcome favorable to both A and B. Number of, okay, which is divided by number of cases favorable to B. That is the equation to finding P of A given B. N of A intersection B divided by N of B. Okay. Yes. So Venn diagram is given. A intersection B is given. Okay, that is the N of A intersection B is given, and N of B. B is the set B and the number of cases favorable to B. Okay. Yes. And then N of A intersection B becomes P of B by, yes, probability of A intersection B by probability of B. Okay. So P of A given B is probability of A intersection B divided by probability of B. And if P of B given B is probability of A intersection B divided by P of A. Okay, that is the number of here, the number of, yes, A intersection B and B, that becomes P of, if we divide it by N of S, that means the sample space, the number of cases favorable in the sample space, that is, if we divide it by N of S, okay, we will get P of A intersection B and P of B. Okay, yes. So probability of A given B is probability of A intersection B by probability of B, and probability of B given A is probability of A intersection B by P of probability of A. Okay. Next is the extension of multiplication theorem. Extension of multiplication theorem. That is, if A, B, C are multiplication theorem has been studied, the extension of that theorem. Okay, A, B, C are three events associated with a random experiment. Okay, they are events. Okay, of a random experiment. P of A intersection B intersection C is P of A into P of A by B given A into P of C given A intersection B. Okay? Yes. So by definition of conditional probability, P of C given A intersection B is P of C intersection A intersection B by P of A intersection B. Okay, we are just substituting the equations and you will get the answer. Similarly, if A1, A2, etc. An is n events related to an experiment, okay, then this is the multiplication theorem. Okay, so this is the extension of multiplication theorem. Next is independent and dependent events. Okay, two or more events that are not mutually exclusive may be, that means inclusive events are divided, okay, are classified into independent and dependent. So what are independent events? Yes, the set of events are said to be independent if the occurrence of any one of them does not, that is in the way, if the occurrence of any one them does not in any way, that is affect the occurrence of any other in the set. For instance, if we toss a coin twice, the outcome of the second toss will no way be affected by the outcome of the first toss. Okay, outcome of the second toss is not affected by the outcome of the first toss. That is, they are independent. Okay, that is independent events. The occurrence of the first event is not affected by the occurrence of the any other in the set, that are independent. So from the name itself, it is independent. And dependent means two events are said to be dependent if the occurrence or non-occurrence, if it may be occurred or may not occurred, of the event in any trial affects the probability of other subsequent trials. Okay, that is occurrence. If that event is occurred or not occurred, it affects the probability of the subsequent trials. Okay, so if the occurrence of one event affect the happening of other, it is said to be dependent event. That means if two cards are drawn from well shuffled pack of 52 cards, then one after the other with replacement, then getting an ace in the first row, getting a king in the second row are independent events. But if the card drawn in the first row is not replaced, okay, that is not replaced, one card is drawn. If not, it is not getting back into the position of 52 cards. Okay, then it is just 51. Okay, that remaining it's 51. It is that is the outcome of the second row is dependent of the first row. Okay, like that. I think it is clear for you. Okay, that is independent and dependent events. So just as a equation, that as a definition, an event E is said to be dependent of another event F when the actual happening of F does not influence any degree of probability of happening E. Okay, and if the probability of happening E is dependent or influenced by the previous happening, okay, then E is said to be dependent on F. Okay, it is the proper definition of dependent and independent events. Okay, yes. Next is the probability of independent events. How will you find the probability? Okay, if A and B are independent events, then P of A given B has occurred, which is precisely named as P of A. P of A. That is, A is not affected by B. That is, P of A given B is P of A. Similarly, P of B given A is P of B. Okay, for independent events, A and B are independent. By multiplication, okay, rule of probability, P of A intersection B is P of A into P of B given A as definition. From definition, P of B intersect P given A is P of A intersection B by P of B. Okay, that is the equation, the definition. From the definition, what is P of A intersection B? That is given. And P of A given B is P of B, and P of A given B, P of B given A is P of A. That is 2 is given. Okay, and so that A and B are independent, P of A intersection B is P of A into P of B. Okay, that is P of B given A is replaced by P of B, and P of A given B is replaced by P of A. Okay, yes. So P of A intersection B is P of A into P of B. I think it is clear. Okay, so this is the rule for independent events. So P of A intersection B is P of A into P of B. So there are 3 conditions for A and B to be independent of any one of them. May be used as a test of independence. What is that? P of A intersection B is P of A into P of B, and P of A given B is P of A, and P of B given A is P of B. Okay, these are the 3 conditions. If you have to check the event is independent or not, you have to check these 3 probabilities. Okay, yes. Next is similarly, if there are extended number of independent events like that, then P of P1, P2, etc. n, and P of A1 into P of P2 into etc. P of A. Okay, if this A and B are dependent, okay, A and B are dependent, these P of A intersection B not equal to P of A into P of B. Okay, yes. So that is the first remark, and second remark is if events having non-zero probabilities are independent, it is not equal to 0, that is A intersection B is not equal to 0, and hence 2 independent events having non-zero probabilities cannot be mutually exclusive. It has non-zero probabilities which cannot be exclusive. Okay, that is given. Okay, just a theorem like that. Okay, please go through this theorem. It is not important, but you have not to go to the proof. Just read that. It will be useful for the problems to solve problems. Okay. Okay, sorry. That is this probability of independent events is this, and the last is this theorem. Okay. These 3 parts, A and B, B dash are independent, A complement and, sorry, it is not dash, it is complement. A complement and B are independent, A complement and B complement are independent. What will be the probabilities? Okay, so these are this. And I will, I am not explaining the problems here. Okay, please go through the many problems have been solved according to all these equations: conditional probability, mutually exclusive, inclusive, according to the multiplication, rule of multiplication, and also independent and dependent events. Okay, the equations has been given for you. Please go through the workout problems and the exercise problems in this chapter. Okay, I am not explaining because with I will be clarifying your doubts in the revision. Okay, in the revision section I will be clarified that doubts. Okay, so please go through that exercises and workout problems, and write the important points on your notebook. It will be easy for you, it will be useful and easy for you. Okay, I am not giving you notes because I am not just injecting that. Okay, please, you have that knowledge to write notes from the given this video. Okay, so please write those points that are important in this chapter, and then try in this, not in this chapter, all the chapters. Okay, please write those important points. Not you have to write the paragraphs, you have to write the important points from this all the chapters. Okay, I'm not that giving you that specific notes for you. Okay, that is, I'm not ready to that, I'm not ready like that, not like that, I am not supposed to give. Okay, according because of that time limit. Okay, so please understand, you have to check out this problems and workout problems and do the exercise problems also. Okay, I hope all of you understood the class. Okay, if you have any doubt, you can check it, you can point it and ask me at any time. Okay, so thank you students, have a nice day.